Hey guys, so my topic is, as you can see, area underneath the curve. So we will begin by talking about why we need area under curve, what is it used in, and how do you solve for it. So to begin with, the why. We use area underneath the curve to find things such as distance, speed, or things such as acceleration even. By using area underneath the curve, you will be able to determine the distance of an object, the speed of an object, or even the acceleration. What is it used in? It is primarily used in things such as engineering or even in mathematics, believe it or not. I know I was surprised too playing, but yeah, these are the main two areas where you would be able to use it in real life situations. How do you solve for this, you may ask? The key word is integrals. Integrals are used to help find the area underneath the curve. Okay, so now we're moving on to a basic definition of area underneath the curve. So there's a keyword area. So I'm pretty sure you all know what area is, but to give an example, take like a square for example. When you're looking for the area, you're looking for a general section within that square, and in a mathematical way, you would solve for the area by multiplying side times side. Another word that is pretty intuitive is curve. This sets this certain topic apart from a standard area, because rather than looking at an area of just like a square, you're looking for one like on a graph in between a certain curve, such as this parabola, for example. Uh, so the only question now is, how do you do that? Now, next slide. Okay, so I like to basically think of three certain things when looking for the area underneath the curve. And the first main thing is, what is my f of x? Your f of x can range from anything such as the sine of x to things such as cosine of x, or even to a function such as tangent of x even. These can all be your f of x, but you got to make sure to locate it. Now the second thing is to locate your points. This is fundamental and important, for it will give you your area underneath the curve. They're given in they're usually given in x forms, and your a will oftentimes be the lower number, or like the one farthest to the left, and your b will also be the one that is like highest, or the one farthest to the right. Farthest right. Okay, and lastly, the most important thing you need to know is how to plug it in, and the formula for which you need to plug it in. This formula is given as the integral from a to b, a to b, f of x dx. We'll start with our first example so you guys can know how to work them out. Okay, so we'll have a function f of x equal to 7 minus x squared, with the points x equal to -1 and x equal to 2. So how does that look like, you may ask? It looks like an upside down parabola with your points -1 and 2. So this is the general section of where you're going to look for when you're finding the area underneath the curve. And since it's only one equation, our bottom in this case is 0. So if you were to have like a second function underneath the primary function, then you would just find the area in between those two curves, and it gets more complicated with that, but for now we're keeping it simple. So we're looking for this generic area in between this section, and in order to do that, we need to define what our numbers are. So we have our f of x, and then we have our x equals -1 and x equals 2. So your a is going to be the lowest number, or the one farthest to the left, which is -1, and your b is going to be the farthest to the right, or in this case 2. So now that we have that down, we just take the integral of it from -1 to 2 of our f of x, 7 minus x squared dx, and then you should get 7x minus 1 over 3x cubed from -1 to 2. So since now that we integrated our f of x, we now have like the antiderivative function, I believe is what it's called. Don't dock me on that. So now all you do is you basically just plug in your x's 2 and -1. So you would do 7 times 2 minus 1/3 of 2 cubed. That's 1. And you subtract it to the -1 because that is a lower number and you always want a positive area. So that's 7 times -1 minus 1/3 -1 cubed. And you should, if you calculate it right, you get, I believe the area is equal to 18. And yeah, that's basically how you find like an area under a curve that's like in respect to the x-axis. You could also do it in respect to the y-axis, and I'll show you that in a little bit perhaps.